Hello everyone and welcome to lesson 5-1, so it's lesson 1 from chapter 5, Algebraic Expressions. This lesson is found on page 349. Algebraic expressions, that means we're going to write numerical expressions including letters. Okay, that it's inclusive of letters. But we don't call them letters in math, we call them variables. So a variable is a letter. Okay? A variable is a symbol that represents an unknown quantity. For example, n, at this point stands for number, plus 2. So any number plus 2. If this is 10, our equation in total would be 12. An algebraic expression such as n plus 2 is an expression that contains variables, numbers, and at least one operation. This is the operation. So we have a letter, an operation, and a number. And there's our variable. We call them variables. Write each of the following phrases in the correct section of the Venn diagram. Contains an operation, has variables, and numbers, has only numbers. Okay, let's see. So characteristics of expressions. We have numerical expression and algebraic expression. A numerical expression has only numbers. Okay, so there's only numbers. While an algebraic expression has variables, and numbers. It has both. It has letters, variables, and numbers. What do they both have in common? They both contain operations such as addition, subtraction, multiplication, or division. Right? They all do. A real world link. The expression parentheses f minus 32 times 5/9 can be used to convert a temperature from Fahrenheit, okay, we put the Fahrenheit there, to Celsius. Fahrenheit is used in the United States and Celsius is used in Venezuela or Canada. In this algebraic expression, the variable f represents the temperature in degrees Fahrenheit. So if you were to have 62 Fahrenheit, that's your degrees in temperature, you would insert this number in here. So you would replace this variable with 62 and then you solve. You solve parentheses first, you follow order of operation. So you would subtract 32 from 60, so you get 30, and then you take 30 and you multiply it times 5/9, and that will be your temperature in Celsius. Now let's look at how to write algebraic expressions, okay, or how to evaluate. Whenever we have a number next to a variable, the operation that happens in between them is multiplication. So you see 6 times d. And here we have a number and two variables, st. It's 6 times s times t. mn is m times n. And a cubed is a multiplied into itself 3 times. A times a times a. You're probably wondering, but wait a minute, how do I multiply these variables? How do I multiply these letters? Well, we don't know the value of these yet. But for example, if I were to tell you in this one, d equals 2, you could tell me that this equals 12 because it's 6 times 2, right? Because d equals 2. But I'm just making those values up. I don't know that. It's not a rule. I'm making it up. This is what we're solving for. I could tell you here that s, every time you have s has a value of 3, and you could say that t has a value of 2. Just for saying. So here you will multiply 9 times 3 is 27, and 27 times 2 equals 54. So your answer here would be 54. And that's how it works. The branch of mathematics that involves expression with variables is called algebra. In algebra, the multiplication sign is often omitted. So this is algebra, boys and girls. The numerical factor of a multiplication expression that contains a variable is called a coefficient. So 6 is the coefficient of 6d. So the numerical factor is called a coefficient. Okay? Expressions like y over 2, so y divided by 2, can be written as y divided by 2 or y times a half. Remember, this is the multiplicative inverse. Here we have 3 examples where we replace the variables with numbers. You're given the value of n. n is -4. So we just replace the variable. Here you're also given the values. You see this? W is 5 and V is 3. Replace the variables. And so on. Please take a look at these 3 examples on your own. Pause the video now and look and follow the step process. For the sake of saving time, I will not go into each one in detail, but I will do these with you, okay? Step by step. What I'm going to do right now is I'm going to replace the variable for each one, knowing that C is 8 and D is -5. Knowing that, I'm going to replace this C with 8, this C with 8, but I'm going to replace this D here with -5. So I'm going to do that to all of them. Okay, when you're done, you should have something that looks like this. Okay, so let's see, for the first one, I replace the C with 8. So I have 8 minus 3. 8 minus 3 is simply 5. I will do that with a different color so that you can see the difference. It is 5. Okay, and then I replaced the C here again with 8. So it's 15 minus 8 equals 7. And then for this one, I replaced the C and the D. Remember that by order of operation, I have to do parentheses first. PEMDAS. PEMDAS, the first letter is P. PEMDAS. So we have P parentheses, exponent, multiplication, division, which can be interchanged. Addition and subtraction, which can also be interchanged depending on which one comes first. These two can be flipped, but these two cannot. So you always do parentheses first, everything inside the parentheses. So I replaced the C with 8 and the D with -5. Now it's D and C and D. I could have written 8 plus -5, or I just replaced the negative because it's still taken away. When you have 8 plus a negative, it's still subtracting. Okay, so now I do the parentheses first. So my next step will be 3, and in the parentheses I'll also have a 3. So 8 minus 5 is 3. And my answer will be 9. 3 times 3. Okay, next I replaced, as you can see here, the C and the D with C is 8 and D is -5. So I'll solve the multiplication first. As you can see here, multiplication is first. Okay, it's before subtraction. Subtraction will be last. So this operation I will do last. So I have 2 times 8 is 16 minus 4 times -5, it's actually -4. Got it? It's -4 times -5. Because yes, this is a number that I'm taking away 4. So this whole thing is together. So -4 times negative. Negative times negative is positive. Same symbols. Remember that. So same symbols is going to always equal positive. -4 times -5 is going to equal 20, but positive 20. So the symbol changes to a positive, and I write 20. So 16 plus 20 is 36. This is where it starts to get a little tricky, boys and girls, so you have to pay attention to the symbols when you're multiplying, dividing. Okay, now I had to replace for E, the D minus C squared. D is 8, D is -5, as you see, and C is 8, and I replace the C. Okay, first I have to do parentheses. There's no parentheses. The parentheses is already just 8, it's already solved. Next is exponent, so I have to do the exponent. So my next line is going to look like this, -5 minus, and this minus is not part of the exponent, that's why the parentheses, that's why it's not inside the parentheses. Okay, so we still put the minus sign there. It's not like this one. Okay, it's not like this one. So here we have 8 times 8 equals 64. Now I have -5 minus 64, so all of these minuses are going to equal to a bigger minus number, -69. Okay, and finally F. Let's follow the order of operation, okay, where we have PEMDAS, P-E-M-D-A-S. I don't have any parentheses, so parentheses done. Now I have exponents. Yes, I have one exponent there. So my next line is going to look like this. Still I have my 2 times, it's -5 times -5. -5 times -5 is going to be positive 25. Okay, plus I can go ahead and solve this now because I have to do multiplication before I do addition anyway, so I can solve this. Positive 5 times -5 is going to equal -25. Okay, and now I have 5 times 2 equals 50 plus -25, or remember this plus -25 is just like saying 50, just like saying it like this, 50 minus 25. It's the same thing. Okay, this is the same thing as this. And we get our final answer as 25. So these are your final answers there, boys and girls. You don't see them. Okay? For each letter. If you have any questions, make sure to ask in class. Now we're going to include division. Okay? And this is a formula used to find a person's heart rate. Okay? They're training. Athletic trainers use the formula 3 parentheses 220 minus A. A is H over 5, where A is the person's age, to find their minimum training heart rate. Find Latrina's minimum training heart rate if she is 15 years old. Okay, go ahead and see how the variable is replaced, see the order of operation, and lastly, the division is done last. Okay, but the parenthesis is solved on the top first, and then multiplication and division. And there's your final statement. Let's try G together. Okay, here we have a little geometry. To find the area of a triangle, use the formula base times height over 2, where base is the base and h is the height. What is the area in inches? Sorry, what is the area in square inches of a triangle with a height of 6 inches and a base of 8 inches? Height of 6 inches and a base of 8. So here's our base of 8 and height of 6. These are all inches, of course. I didn't write it in. And then all of this will be divided by 2. And the reason it gets divided by 2 is because if I actually multiply 6 times 8 times 6, I'm going to get this entire area up here too. But it's really only half. This is only half of that because we don't have this other part. That's why we divided by 2. So we have our formula. Now let's replace the variables. Base is 8 and height is 6. All over 2. When I multiply 8 times 6, I get 48 over 2. And now 48 divided by 2 is simply 24. 24 square inches. Or 24 inches square. They're both fine. Sometimes we will be given a word problem where we actually have to identify what we're looking for. It's the variable that we don't know. It's the one thing. So write expressions. To translate a verbal phrase into an algebraic expression, the first step is to define a variable. Okay, find out what it is that you're looking for. When you define a variable, you choose a variable, any letter. If it's C for cash, you can use N for number, A for apples. So you choose a variable, you choose a letter to represent the unknown value, the unknown quantity. So number 5. Please take a look at this example on your own for the sake of saving time. Read it and you'll see how we've determined a variable for weeks by using W. And see how it works and then read the conclusion. And for example 6, you can see that they solved the example from 5. Okay, that they brought the context from number 5 and they actually solved it using the variable of 11 weeks. Oh, we go on to use that same context as an example for number 6, and now we can solve it. We understand that it's 11 weeks, so we're going to take that W and replace it with the number 11. Okay, so because 10 plus 10, 25 plus 10 weeks, 25 plus 10 per week is being replaced, and weeks being replaced with 11. Okay, let's try H. An MP3 player costs $70. Okay, so we have our $70 that we have to spend to buy it. And song downloads cost 85 cents each, 0.85 each. Write an expression that represents the cost of the MP3 player, there it is, and X number of downloaded songs. We don't know how many songs we're getting, but we know that each one costs 85 cents. Then find the total cost if 20 songs are downloaded. So number of X is going to be replaced with 20 songs. So now I have my $70 for my MP3 players plus 85 cents per song, and it's 20 songs. I do multiplication first, and I have my 70 plus 85, decimal 85 times 20 is 17. Okay, and now I just add those two together, and what is my answer? I have $87. It's going to cost me $87 for my MP3 player, and with 20 songs. Please leave the guided practice for class. Complete the whole independent practice, including the back. See you in class.